Okay, here's the first test review. So we're going to be doing some factoring here. This, two numbers, negative 42 when you multiply, negative 11 when you add. So that's how you get the x squared, x times x. Right, what is that? That is not 6 and 7, that's 14 and 3. 14 and 3. To get to negative, or more negatives. Okay, so that should be the answer. So x equals 14 and x equals negative 3. Okay? Right, now this one you can do two ways. This can be factored. In other words, that will turn into that. That's the difference of squares. Okay? So again, x equals 5 and x equals negative 5. But you could just do this. Add a 25 to both sides and square root. You're going to get plus and minus. Remember when you square root plus and minus, so you'll get the same answer anyway. That's probably, I prefer doing it that way, it's a bit quicker. Now this is definitely square root both sides. You don't have to FOIL this or anything. This is just if you square root the left, you get x plus 3. If you square root the right, remember you get plus and minus 4. Okay, so that's what I'm looking at working at. So we're going to take away 3 from both sides. Okay, remember this here, I've got to take away 3 from both sides. So I'm going to have the 4 take away 3 and the negative 4 take away 3. So my two answers are 1 and negative 7. Okay, right. Right, that's those done. Right, now again, for this one, if you want to use the quadratic equation formula, yes, you can use it for that one as well. But this will factor. Okay, so a 3x squared is a 3x and a 1x. This could be 10 times 1, it could be 5 times 2. I've got to figure out what's the best place to put them, so when I FOIL it, I get 11 in the middle. So I have to sit and think here myself. I think... 3, 5, 2, right, that goes there, that goes there. It's all pluses, which is nice, because these are all pluses. Okay, so let's double check. That's 6x, that's 5x, yes, that gives 11x. Don't forget it's still equal to 0. So the 0 here will be negative 2, so x equals negative 2. And if you need to, put this equal to 0. In other words, actually do this. 3x plus 5 equals 0. Take away 5 from both sides, so 3x equals negative 5. Let's go over here, divide both sides by 3, divide both sides by 3, x equals negative 5 thirds. Okay, so that's just solving that there, because you put it equal to 0. Okay. Right, what's next? Right, inequalities. These aren't too bad. Number line. Negative 1 is a 0, and positive 2 is a 0. I just need to check what values make it greater than or equal to 0. So I like to test 0, something in between these two numbers. You can test a 3 over here, you can test a negative 2, whatever you want to test, away from negative 1 and positive 2. If I test 0, the numerator will be 1, the denominator will be negative 2. That is a negative number. No matter what it is not greater than 0, so this area cannot be true. So this area must be good, that area must be good. In other words, here's the answer. The answer lies between negative infinity and negative 1, okay? And then 2 to infinity, okay, that way and that way. Now, of course, remember, it does have the equal sign in it, so you're supposed to use brackets, but you can't when it's come from the denominator. The 2 cannot have a bracket, all right? Infinities always have parentheses, so that's the answer. Just remember that the 2 came from the denominator, so it can't be equal to 0. Okay, so that's the answer. Now this one, very same kind of technique. I won't do this one as well. That is just factor it first. Now this will factor into x minus, what's that, 6, x plus 3, the denominator. Okay, let's make sure on that one. Two numbers, negative 18 when you multiply, negative 3 when you add, yeah. So this one will just have 6 on a number line and negative 3 on a number line. And I think, because it's less than, it's going to lie in between there. So actually the answer is going to be negative 3 and positive 6. But again, just check your numbers, okay? Check whatever number you want to. Okay, next one. Now this one is the one that you have to use the quadratic equation formula, unless you've used it on one of the other factoring problems. Now remember, the distance is 83 feet. That's what goes on the left, all right? So that's what I've got here. Now, you have to take away 83 from both sides because you're supposed to solve equal to 0. Let's go in order. So the 2t squared, I've got the 5t, and I've got the negative 83. Now, I'm not going to go through this one, all right? Just put that into the quadratic equation formula and come out with a decimal. Actually put it into your calculators and come out with an answer. Okay, domain and range. Right, little arrows on these things. So the domain of this is all the way that way, all the way that way. It's negative infinity to positive infinity. Okay, that's the domain. The range up and down, all the way down and only up as far as, can you see, y equals 3. So the range is negative infinity to 3 with a bracket, because it does include the 3, okay? So that's the range. I won't bother with that one. How about this one over here? Okay, so again, this is the domain. So it's coming from negative infinity, and it only goes as far as positive 3. Okay, the range up and down, but it starts at 2 with a bracket and goes up to infinity. Okay, so domain and range. Let's get rid of some of this. Okay, let's take a look at this one. Right, domain and range, well, just domain of algebraic functions, okay, not graphs. Now remember, all you're looking for are denominators or square roots. Denominators cannot be 0. In other words, x cannot be positive 4 and x cannot be negative 5. The zeros, all right? If that's it, you've pretty much finished. Here's the answer. Negative infinity as far as negative 5, and then the negative 5 to the positive 4, and then the 4 to infinity. Okay, that's how it is in interval notation. So denominators can't be 0, and inside a radical must be greater than 0 and equal to. Okay, so whatever's inside, you do that. That's all you have to do and solve. You take away 5 from both sides, you divide by 2, that's the answer. Okay, but in interval notation, let me have some space here, I'll write it above. In interval notation, greater than negative 5 over 2 is this, negative 5 over 2 to infinity, bracket, because of the equal sign, okay? Nothing to do with denominators here, that's it. Right, let's keep on going. Use the graph to determine the following. Right, relative maxima and minima. Okay, right here is a minimum, all right? The minimum is negative 5. Where's that? So I'm going to do that one first over here. The minimum is negative 5. Where does that occur? It occurs at x equals negative 2. The maximum up here is that negative 1. Let me just erase that. Okay, there's the maximum. That's at negative 1. Where does it occur? At x. Is x equals 0. It occurs at x equals 0. So that's it. That is what you're doing for maximums and minimums. Okay, top of the hill, bottom of the slope, what we want to call it. Now, where's it increasing and decreasing? Right, well, the only part that's increasing on this one is this part here, okay? Between what? X numbers, not Y numbers. It increases between negative 2 and positive 0. Now, look, you're going to be using these. If you've got these are the X numbers. So it's increasing between, where's that? Negative 2 and positive 0. That's where it increases, okay? That part there. Right, where's it decreasing? It's decreasing here and here, okay? And again, that is from negative infinity to negative 2, using the negative 2 again. So it's decreasing from negative infinity to negative 2. And also, can you see if it's over here, over on the right, again, from 0, this is 0 line, x equals 0, to infinity, okay, that way. Okay, so there you go. Increasing there, decreasing there, okay? And be careful, just watch it. Suppose I give you one like that. Okay, then this is the part that's decreasing, all right? Only one place, and these are the parts that are increasing. So remember that if it's that way around instead. And now actually, I think I also have, now it's not on here, it's just squeezed on at the bottom, because you're also going to have what's the average rate of change on the graph between the two values that you've already found. Remember the negative 2 and positive 0? So the question down here, which is missing, is average rate of change between negative 2 and 0. Well, again, there's negative 2, there's the point. There's 0, there's the point. It's just rise over run. I can see it goes up 4 and over 2, 4 over 2. It's positive, make sure it's positive. This is positive. There you go. That's the average rate of change, okay? Let's keep on going. Right, no, I'll stop there and do another video. There you go, that's enough for now.